Welcome back to the 14th video about my electronic steering wheel slash rudder jog project IP68. In the previous video we machined here on the mill these features here, that big pocket and that groove in the main body. Card here, link in the description. In this video we will do the roundtable operations on the other side. Enjoy! If we have a look at the drawing, we're talking about making a round stub here. That's the front side. A round stub here. That's our center hole for the shaft. That is, we have to machine out that feature here, and you see that's outside operation. And then in a second step we also need a groove here for the second O-ring. That's all around here. And yeah, that outside milling on the round table will pose a problem. You see, if I place here, is everything clean? Yep. If I place here my piece on the round table, yeah, it's reasonably well centered here. There's not much wiggle room, or there's basically almost no wiggle, which is good. However, I clamp it down. I cannot go around anymore because wherever I put that clamp only partially, it will block at least part of the stuff I want to mill away. The only solution would be to clamp it from the inside, but that would require that I have some kind of thread down here where I could thread through my centering shaft some kind of threaded rod all the way up to here, and then with a big washer and a nut clamp it down. That would be the good solution. the professional solution, but we're not professional here. I'm just fooling around. So I will try from my little round table clamping kit I have meanwhile to clamp that down in a way so I can at least work on a larger portion, and then we will change that clamp over and work on the other side, and we will see how that works. That was 3 work in a row. So give me a sec. In a first step I will attach 2 helpers here with 2 T-nuts on each side, and that's really pressing the whole thing together. So that could actually be enough, but I'm not sure about that. I mean, this is kinda clamping that in like a vise, but as you may have been able to see, not quite like a vise, so I'm not trusting that alone. I added a third bar here connected to my 2 helper bars. Yeah, they're clamping a little bit, but that's not enough. And now that thing isn't moving at all. That's good. Okay, now I need the right cutter here to go down 30 millimeters on the outside. So the last cutter I used for the 16.4 millimeter deep hole in the bottom, that's not gonna work. I don't want that chatter I have with interference of a too short cutter with the walls of my pocket. And I'm going here from the outside in the inside, so I would have all the time, that interference, and this part here that will be left over is actually visible. So I want it to look reasonably good, so I need something else. 1 second, please. That cutter should do the job, at least it says here on its little box. You can't probably read it, but it says 40 millimeters here. The actual area where it cuts. So yeah, hopefully that works. I fed the cutter down here not quite 30 millimeters. I have here a mark at 30 millimeters, and I will round off first the 2 front edges a little bit until I can use my caliper to measure the actual depth we are at, and then I feed further down until we hit our 30 millimeters, and then I will lock the Z-axis and we do the rest inwards until we can measure a radius here, which should be how much should be left? 28 millimeters should be left here as a diameter in the middle. Guess the ledge we created here is big enough now for a measurement. So let's try that. And we are 28.8, I'd say. Yeah, 28.8. So I fed down 1.2 millimeters. That should get us to exactly 30. And I'll do one more go with original sound. And then we see again where we are. I think you can see here we hit exactly the mark I made. So let's verify that with a caliper. So we are at 29.98, 29.93, and I'm not perfectly perpendicular. 29.98. Yeah. I guess I take that. And now comes the boring task of just feeding further in until I hit here my inner marks. And if I get close to them, we'll stop again and measure the diameter. Okay, it's time to take a break for several reasons. The first being you have to appreciate the mess we are making here. And now, after I cleaned up a little bit, I can tell you the second and more pressing reason. Up to now, I was feeding here on the x-axis because I'm bumping here at the back with my y-axis on the column. Though that was as far back as I can go. But now I can no longer feed on the x-axis because we're just, passing here. So I will now center on the x-axis the whole assembly up here on my tool, and then I can feed on the z-axis, which is very important. And when we get closer to our final diameter, because if that's centered up and I feed here 1/10 of a millimeter, we actually take off 1/10 of a millimeter. And that was here with that offset arrangement with feeding on the x-axis absolutely not a given. So let's continue the carnage. Absolute carnage, I tell you. This time I stopped, yeah, so you can have a nice look at that again. But mainly because I think we're starting to getting close to the mark. So I will clean up again and then we have a measurement how far we still have to go. But it can only be a few millimeters. So let's see. Down here we are at 32.5 and up here 32.7, 25. Okay, we have to get down to 28. Yeah, let's forget about the chains for now. I will measure that again a little bit later and feed 2 times half a millimeter, so 1 millimeter in. Then we should be at 28 point something. Sorry, forgot to press to record. We are already a millimeter in. Let me clean up and we measure again. And yeah, I will give you the last pass with original sound or something. So if I'm right, we should be at 18. Point something, 28, and it says now here 28.3. Okay, that sounds okay. And at the top we are at 28 point, it's hard around the camera, 34, 35, 28.36, 37, 35. And down we are at 3.0. Okay, so I would say I will feed in 0.15 and then we should be where we want to be. This time as promised with original sound. And you might have noticed that I'm always feeding in when I'm at that end of my, well, not quite circle, semicircle. And then I'm only taking material off when I'm turning into that direction and then returning to my initial position here without taking material off. And that's basically because of the rotation, the direction of rotation of my cutting tool. If I would cut also in that direction, the cutting tool basically sucks in the material instead of cutting it, and it's really hard to control. So it feels much better if you're just taking material off while rotating that way. Okay, anyway, let's go to start and feed in 0.15 millimeters. That is basically nothing to the noise I had before. Oh well, the high frequency pitch is the same, but there was much more bass when I went to the other direction. Okay, let's measure again. Okie dokie, we are at... Oh, look at that, 28.01, 28.02, and up here we have a little bit more, 28.07. Yeah, I'll guess I take that. Okay, next step. So, to do the rest here in the back, I will clamp that down now here. And the important thing, that was a mistake I made on the other side, I first fasten that clamp here to my little helpers, and then I will release the old clamp here so we have a space around the other side to, mill the rest off. Now that the new clamp is in place, I can remove the old one, hopefully. Okay, so in the first step, I will, with everything all axes locked in the last position, at the last known position, we will go here through the full of the material and close the circle around our, inner cylinder. I was not sure in the beginning. I only fed in 0.5 millimeter on, each round I took, or half round, 3/4 round I took, if the machine can do it. But as you can see, I got a little bit adventurous here, and it seems it is doable. The advantage of doing it that way, the disadvantage obviously is putting a lot of strain on the tool, on the material and the machine, but the advantage is here. I have now my radius set, and if I just go through and nothing goes wrong, I'm exactly at the radius, the diameter I want. And then I can move outwards and remove the rest here. While if I start again from the outside and taking off only 0.5 millimeter steps, I have to somehow blend in again to the radius I already created. And that probably won't be easy, and I probably mess it up. So we do it that way. The hard way, but exact way. Okay, now you can see from that perspective quite well how we basically forced our way behind the finished part of the cylinder in the center and went through the waste material. And please note that since we locked all axes, there is not really maybe a little mark visible. I'm not sure. We will see when we take that out at the end and have a review of what we've done. Anyways, a long time lapse removing all that stuff here. Time for another break, and I think I made a significant dent here somewhere into the piece. Let me first clean up the glorious mess. So, in general, I was at the end of the travel on the y-axis, so we have to change to the z-axis again. And you see, sometimes I got, the whole thing got sucked up for some reason. And that's not bad here. It's, this is all extreme magnification, but that's bad. That gouge is a few millimeters deep. So it's really deep. That hurt. And I suspect that feeding from inside out was maybe not the brightest ideas ever. After I cut the half moon on, sorry, where's my finger? The half moon on the inside, I should have moved out the tool and then do it again from the outside because I knew that worked. But yeah, I got lazy and that's the result. Yeah, there are some other points where there are some irregularities where it sucked the whole thing up. So basically, I don't know where the slack came from, but it must have sucked the whole stack up into the tool to make these marks. Again, I hope this is only cosmetic, but yeah. It hurts. Let me reset everything and then we mill off the back the rest from the outside. Everything's reset. We will now feed from the outside on the x-axis and mill the rest off. I popped the Valium and the antidepressant, so I'm fine now again. That went not completely without hiccups, but at least without catastrophes, as you might have noticed in the time lapse. When there was only very little material left, on either sides, I went very carefully and advanced only 1 or 2/10 of a millimeter each time and was very careful when feeding in. Otherwise, funny things happened. Generally, I went again only a half millimeter feed in each round in the beginning before I experienced the problems, and you saw it. Anyway, at the end, I went with about 3 millimeters advances inside again over the surface here in the hopes that I can clean up the catastrophes I caused beforehand. We will see. Let me clean up this stuff a little bit. Now that I cleaned up the whole thing, you can see, okay, the going inwards here worked partially here on that part. What's that? There's a little ledge. This looks awful. That was the first time I had a little, the whole thing got, or the tool got sucked in. And I should have stopped here. There is a second spot. I can feel it. Can you see it? Right here, that was worse. So this is a dent. There's another one. But that didn't stop me. Like in this, airplane crash analysis. I was a pilot totally fixated on landing, and I ignored the first warning, and I don't know what that was. I can't remember it. I ignored the second warning, and then we got the catastrophe. So not very nice. I hope the part will still work. We will see when we cut the groove for the O-ring, which would be the next roundtable and last roundtable operation on that part. And if I remember right, the last roundtable operation of that project. Okay, so let me set up for cutting that groove here for the O-ring. I made some rough sanity marks here with, just scratching it with the caliper to roughly align my tool. And can you see that back there? Yeah, we are a little bit on the outside. However, if we go to that position, we are a little bit on the inside, which is to be expected because remember, I'm not completely centered here. And okay, that you probably can't see unless I move my camera, which I won't, but here we hit the mark. But yeah, in that close-up it really looks horrible. But I will also measure now before we start. If I can zoom out again, thank you. That distance here between my center shaft and the shaft of my tool. That should be all around 45 millimeters if my calculation is right. I'll come back to you if I've done that. Makes really no sense filming that because most of the time you won't see anything because everything is in the way. So here's what I did. I went around all my 3 positions I can access here and tried to measure that diameter with the caliper, which should be ideally 45 millimeters. Here we are now at 45.6 and on the other side we are 44 something. Yeah, I 44.6, also 44 something, and here at the front 45 something. So I'm a few tenths of a millimeter off. We can have a look again at my, let's call it scratches. Please note the scratches themselves are also not exactly on spot. So here we are a little bit on the inside. Here we are a little bit on the outside. And here you can't see it again. I'm sorry, but yeah, a little bit on the outside. It's not really critical where the O-ring is, but the important thing is I think I mostly clear all of the craters I produced. So now let's search for a nice piece of surface like here. And okay, lock my axis here and go down until we scratch. Okay, here we are. And that's my 0. And now we do the whole thing. That is half of it. And then we change the clamping again. Okay, let me clean up and reclamp and then we do the other quarter or so. I moved the clamp from the back to the front and yeah, as I mentioned, let's do the rest. Let's have a look at the result, shall we? Just a quick recap of the other side. You see, I got here a little chatter on the outside in that large round pocket, and that was totally my fault. I should have chosen a longer cutter so I don't have interference with the shaft of the cutter here at the edge. And the groove for the O-ring is quite nice. it's a little bit off-centered, which is also totally my fault. Now, I can't do it. I can't do it. Yeah, we have to do it. So, yeah, the other side. The first thing you notice going from the top down, I have here milled on a little bit different radius, and there's also a little dent here. This happened probably when I changed the clamping. I thought I did it right, but obviously, there was still some movement. And remember, I told you in the beginning the right way to do it, if I had the ability, would be to have a center shaft that is attached via a thread or something to the round table, and then with a big washer clamp it down from the top. That would have improved things, definitely. Moving down here to the surface, that was the part we initially did. Coming from the outside in with the cutter, and that looks quite okay. Let me focus down a little bit more. That looks quite okay. And then I had the idea, okay, I'm changed the clamps and going around here to keep my radius, which worked not perfectly, and went from the inside out with the cutter, at least initially, until I made one little dent, but I didn't care. I continued, and I made another little dent on the other side here, right where the groove for the O-ring is. It's almost disappeared. And finally, when that happened, I gave up. And I still have no idea where, I mean, these are several millimeters, where I have that much vertical slack in my stack in my machine that the tool could be sucked down that far. But that just shows, even with a small 6mm cutter end mill, the forces that you have to deal with. And of course, in that area, the surface is awful. And that's completely on me, okay? That little eccentricity, not eccentricity, but changing the radius here, that just happened. Yeah. And then when we did the second quarter around here, so you can see the surface down, that's a scratch I just made when cleaning it up. Yeah, it's not so nice. And oh, I forgot that. There the tool got sucked in too when milling the surface here. So yeah, there's also a little visible step here. And you see the surface here is not so nice. Yeah. It's but ugly. Will it work? Probably yes. I mean, at least the O-ring is fitting perfectly in here. So, yeah. There's a lot, much room for improvement. And, yeah, I'm not redoing the whole part, at least not now. Maybe if it turns out it's really too subpar, I will do that. But for now, let's move on. That's it for today. Yeah, that was quite an adventure. And yeah, most of it was my fault. Okay, there's No doubt about it. Yeah, the machine is maybe a little too small, too weak for a part that big, but yeah, if I have worked a little bit more carefully, thought a little bit more about what I'm doing, it could have been better. Anyway, next week we only have a very short video, probably finishing up that part, cutting some threads into it, and then we're finished with that thing. Till then, bye.